Everything you were taught about human history begins with a single assumption that we are first, that before our cities, our circuits, our satellites, there was nothing. Just silence and stone and creatures that never looked up at the stars and wondered. That assumption feels safe. It feels logical. It feels, above all else, permanent. It isn't. Here's the question that geologists, archaeologists, and planetary scientists have begun asking, quietly, carefully, in ways that don't make headlines. What if intelligent, technically advanced civilization existed on Earth before us? Not once. Maybe multiple times. And what if the reason we can't find the evidence isn't because it doesn't exist, but because the Earth itself has already destroyed it? You are not early in the story of this planet. You may be very, very late. Earth is 4.5 billion years old. Complex life has existed here for roughly 600 million years. Modern humans, our specific version of intelligent, tool-using, civilization-building humans, have been here for approximately 300,000 years. Of that time, we've had recognizable urban civilization for only about 6,000. That's a fraction so small that if you compressed Earth's entire history into a single calendar year, all of recorded human civilization would occupy less than the final half-second of December 31st. In that remaining year, those hundreds of millions of years before us, something extraordinary could have risen and fallen completely, and the planet would have simply moved on. No monument, no memory, no trace. That is not a fringe idea anymore. In 2018, astrophysicist Adam Frank and geoscientist Gavin Schmidt published a paper in the International Journal of Astrobiology that introduced what they called the Silurian hypothesis, a formal scientific framework asking whether geologists would even be able to detect an industrial civilization that existed tens of millions of years ago. Their conclusion was sobering. In most cases, no. We wouldn't. The geological record is incomplete, discontinuous, and aggressively erased by the very forces that keep this planet alive. Plate tectonics recycles the ocean floor every 200 million years. Erosion grinds mountain ranges into sediment. Forests consume ruins in decades. The ocean buries everything in silence. If a civilization existed 50 million years ago and built cities the way we build cities, used energy the way we use energy, extracted minerals the way we extract minerals, we would likely find nothing. A faint chemical anomaly in a rock layer, perhaps? A slight spike in certain isotopes. Nothing more. The planet doesn't preserve civilizations, it digests them. And this is the part that most people have never sat with long enough to feel the full weight of it. We assume absence of evidence is evidence of absence. But that logic only holds if the evidence could have survived in the first place. When you realize that Earth is actively, constantly, relentlessly erasing its own past, you start to understand that the silence isn't proof of emptiness. It might be proof of erasure. Now consider the anomalies that already exist within the geological record. The Paleocene-Eocene thermal maximum, roughly 56 million years ago, was a period of sudden, dramatic global warming. Temperature spiked by 5 to 8 degrees Celsius within a geologically short window. Carbon flooded the atmosphere from a source that scientists still debate. The event mirrors in certain ways what large-scale industrial activity does to a planetary climate. Scientists currently attribute it to volcanic activity and methane release. That may be entirely correct, but the honest scientific position acknowledges that we are working from incomplete data, compressed into stone layers too thin to tell a full story. The same is true for several other anomalous heat and extinction signatures spread across deep time. They have conventional explanations. Those explanations may be right, but they were developed without ever seriously considering the possibility that they needed to account for prior civilization. Once you introduce that variable, even as a hypothesis, the question of whether these events fit the profile becomes genuinely open. But that's not the real problem. The real problem is the nature of time itself. As an antagonist, as an eraser, as something fundamentally indifferent to whether anything ever existed or mattered. Time does not archive. It does not preserve significance. It applies the same geological pressure to a cathedral as it does to a cliff face. Given enough of it, everything reverts. Every empire becomes sediment. Every machine becomes oxide. Every city becomes a layer in a rock formation that future species, if they're lucky, might detect as a faint discoloration in a quarry wall. We know this because we've watched it happen on shorter timescales. Civilizations we know existed, with roads, with agriculture, with infrastructure, with writing, have been swallowed by jungle in centuries. Angkor Wat, one of the largest pre-industrial complexes ever built, was consumed by forest so completely that the outside world didn't know it existed until the 19th century. The lost cities of the Amazon, like entire networks of urban settlements, were invisible beneath the canopy for generations. These are civilizations we have written records of, or neighboring civilizations that reference them, and we still nearly lost them forever. Now extend that timescale from centuries to millions of years, from jungle overgrowth to tectonic subduction, from erosion to ocean floor recycling. The math is not encouraging for anyone hoping to find a clear record. It gets worse. The minerals and metals most useful to a technological civilization, copper, iron, aluminum, rare earth elements, are the same minerals and metals that Earth's geological cycles redistribute, concentrate, and scatter over time. If a civilization extracted and used vast quantities of these materials 50 million years ago, their absence from certain geological strata might actually be the evidence. Not a structure, not an artifact, an absence. A layer of rock that should contain more of something but doesn't. We don't yet have the global geological database to make that kind of assessment comprehensively, but the methodology is possible. The question has been asked, and it has not been answered with a clean no. This is where the argument splits between two different kinds of discomfort. The first is the discomfort of a fringe theory, the kind attached to pseudoscience, to ancient aliens, to sensationalism dressed as inquiry. That version has no serious scientific standing and should be set aside. The second is the discomfort of a rigorous scientific hypothesis that most people have simply never heard, because it upends something we all unconsciously assumed was settled. The Silurian hypothesis is the second kind. It carries no claims of certainty. It carries only the honest acknowledgement that our methods of detection may be fundamentally limited, and that this limitation should be stated plainly. The distinction matters enormously, because one version of this idea asks you to believe in hidden civilizations without evidence. The other asks you to seriously examine whether the evidence could exist at all, and to sit with the possibility that it couldn't. Not because nothing happened, but because the planet is not a museum. It is a machine. A machine that processes its own history, grinds it down, recycles it into new rock, new seafloor, new continents. A machine that has no interest in preserving what came before. A machine that has been running uninterrupted for 4.5 billion years. We are a civilization that has existed in recognizable form for 6,000 years. We have already changed this planet's atmospheric chemistry, altered its biodiversity, shifted its soil composition in ways that will leave measurable signatures in future rock layers. Scientists call the current era the Anthropocene, the age defined by human impact on the geological record. That signature will likely be detectable for millions of years in one form or another. But what if something else left a signature first? What if the Anthropocene is not the first such layer, but only the most recent? What if there are other thin, strange, anomalous bands of rock, bands we've already found and explained conventionally and that might, under a different interpretive lens, tell a different story? We don't know, and that not knowing is not a failure of science. It is science doing exactly what it's supposed to do, admitting the limits of the methodology, sitting with the uncertainty, and continuing to look. The honest answer today is that we cannot rule it out. We cannot say with certainty that we are the first civilization this planet produced. We cannot say that with the tools we currently have, looking at the record that currently exists. What we can say is that if something came before us and if it ended, the evidence would almost certainly be gone. Processed, erased, compressed into the unremarkable stone beneath our feet, which means the silence we've always read as proof of our uniqueness might mean something far more unsettling. The silence might just be what planetary time sounds like. Indifferent, continuous, absolute. 6,000 years from now, if no one is left to remember us, the geological record of our entire civilization may reduce to a thin, chemically unusual layer of rock, barely visible to whatever comes next, if anything comes next, pressed between older stone and younger silence. We built cathedrals. We split atoms. We sent machines to the edge of the solar system. And in 50 million years, the planet will hold all of that in a layer thinner than a human fingernail and move on without comment. Earth doesn't remember. It deletes. Imagine New York City 100 years after the last human leaves it. The glass goes first. Thermal expansion, contraction, freeze cycles. The windows crack, shatter, fall. Within decades, vegetation forces its way through every horizontal surface. Tree roots split asphalt with the slow, indifferent pressure of biology reclaiming what was never really surrendered. Steel begins to oxidize. Structural joints weaken. Within 300 years, most buildings have partially collapsed. Within 500, the skyline is unrecognizable. Within 1,000 years, the Hudson River has shifted its banks, and much of lower Manhattan sits underwater during seasonal flooding. Within 10,000 years, the grid of streets is gone. The material that was New York City, the steel, the concrete, the glass, the plastic, has been redistributed by water, wind, chemistry, and the slow digestion of microbial life into forms that bear no resemblance to what they once were. In 1 million years, there is no surface trace. None. This is not speculation. This is applied geology. This is what we know about how Earth processes material over time, derived from studying the fate of every civilization and structure that came before ours. The evidence is consistent, unambiguous, and deeply uncomfortable. Earth does not accumulate history. It processes it. And the processing is thorough. We have a fundamental misunderstanding of what this planet is. We treat it as a stage, a fixed, stable backdrop against which the drama of civilization plays out. But Earth is not a stage. It is a system. A geological, hydrological, atmospheric, biological system of staggering complexity and power. And that system has one overriding behavior that most people have never truly internalized. It recycles. Continuously, without preference, without preservation. The same forces that build mountains eventually grind them into sand and carry that sand to the ocean floor. The same forces that shape continents eventually pull those continents apart, subduct their edges into the mantle, and reform them into something unrecognizable hundreds of millions of years later. Everything on this planet is temporary. Everything is in transit between one geological state and another, including us, including everything we have ever made. The agent most people think of first is erosion, wind and water wearing away surfaces over time. And erosion is real and relentless, but it is only the surface layer of what this planet does to its own history. Erosion handles the architecture. The deeper mechanisms handle everything else. Plate tectonics is the true engine of erasure. The surface of the Earth is divided into roughly 15 major tectonic plates, moving slowly but constantly, driven by convection currents in the mantle below. Where plates collide, mountain ranges rise. Where one plate slides beneath another, a process called subduction, the material of the descending plate is pulled deep into the mantle and melted. The oceanic crust, the floor of the world's oceans, is entirely recycled through this process on a timescale of roughly 200 million years. There is no original oceanic crust remaining anywhere on Earth. It has all been consumed and reborn multiple times over. If any structure, any artifact, any trace of any civilization ever rested on ocean floor long enough, it is gone. Permanently, incorporated into the planet's interior and remade as volcanic rock. And here is the number that reframes everything. Approximately 70% of Earth's surface is ocean. Any civilization that built near coastlines, and civilizations, for obvious reasons, almost always build near coastlines. Built on material that will eventually, inevitably, slide toward a subduction zone and vanish into the Earth's interior. Our own coastal cities are on borrowed time measured in geological epochs. Miami, Shanghai, Mumbai, Tokyo. All of them sitting on terrain that the planet will eventually reclaim. Not through rising water alone, but through the slow, inexorable movement of the crust itself. But that's not the real problem. The real problem is what happens to the things we assume are permanent. Stone. The pyramids of Giza are often cited as proof of human durability. The idea that if we build well enough, we can outlast the planet's appetite for erasure. The pyramids are approximately 4,500 years old. They have survived remarkably well, which makes them extraordinary even by the standards of stone architecture. But 4,500 years is not even a rounding error in geological time. The question is never whether something survives a few millennia. The question is whether anything survives 10 million years, or 50 million. Or the timescales actually relevant to the hypothesis that concerns us. At 10 million years, even the most robust stone architecture in most geological environments is gone. Physically gone. Not buried, not altered, but dissolved, eroded, redistributed. The specific mineral compositions that make granite or limestone recognizable as worked stone become indistinguishable from naturally formed rock once geological and chemical processes have operated on them for sufficient time. There is no chisel mark that survives 10 million years of hydrothermal chemistry and tectonic pressure. There is no foundation wall that remains coherent after the ground beneath it has been folded, compressed, and heated by burial under kilometers of sediment. At these timescales, the concept of an artifact ceases to have physical meaning. What does survive is chemistry, isotopic signatures, trace element anomalies, ratios of certain molecules preserved in rock layers that tell a story, but a story without images, without structure, without anything a human observer would recognize as evidence of intelligence. The only record that might remain of an advanced civilization after tens of millions of years is a slight statistical irregularity in a geochemical dataset. A layer of rock that contains marginally more of one carbon isotope than models predict. A trace of synthetic molecules that shouldn't exist in Eocene sediment. A pattern in the distribution of certain metals across a geological boundary. Not ruins, not echoes, chemistry, it gets worse. Consider what we already know about civilizations we have direct historical records of. Troy, the city of Homer, of Achilles, of the Trojan War, was considered mythological for centuries. When Heinrich Schliemann excavated the site in the 19th century, he found not one city but 9, stacked on top of each other, each built on the ruins of the last. The city had been destroyed, abandoned, rebuilt, destroyed again, rebuilt again. A cycle of civilizational collapse and renewal compressed into a few thousand years. And this is a city we knew about, a city referenced in texts that survived, a city that was being actively looked for, and it was still nearly lost. Now remove the texts. Remove the neighboring civilizations that preserve the memory. Remove the archaeological tradition motivated by prior knowledge. A city like Troy without those advantages would almost certainly have remained buried indefinitely. And Troy is only 3,000 years old. The forces operating on it, erosion, settlement compression, agricultural disturbance, are trivial compared to what geological time applies to structures millions of years old. The Mayan cities of the Yucatan provide another data point. Tikal, one of the most powerful cities of the ancient Maya, was home to tens of thousands of people at its peak. It had towers, causeways, reservoirs, administrative centers, astronomical observatories. It was abandoned around 900 CE, roughly 1100 years ago. By the time European explorers encountered the region, Tikal had been almost entirely consumed by jungle. The trees had grown through the walls, over the rooftops, around and through every structure until the city was indistinguishable from forest. 1,100 years. 11 centuries. That is all it took for one of Mesoamerica's greatest urban centers to become invisible to the naked eye from ground level. Geological time operates on scales 1,000 times longer than that. 10,000 times. The jungle did in 1,100 years what erosion, tectonics, chemistry, and ocean dynamics do across millions. The jungle was actually gentle by comparison. At least the stones remained. At geological timescales, even the stones are gone. Now consider what this means for the search for prior civilization. We are not looking through clear water. We are not even looking through murky water. We are looking through solid rock, compressed by millions of years of burial pressure, chemically altered beyond recognition, partially or entirely subducted into the mantle, and we are asking whether we can find something that, if it ever existed, would now occupy nothing more than a few molecules in a thin band of ancient sediment. And we are asking this question with methods that were never designed to answer it, developed within a scientific tradition that never seriously needed to ask it until very recently. The absence of a clear answer is not surprising. What would be surprising, genuinely statistically surprising, is if we did find clear evidence under these conditions. The difficulty of detection is not evidence of absence. It is evidence of the efficiency of Earth's erasure mechanisms, operating over time intervals that dwarf everything human civilization has ever experienced. And here's what this means for our own legacy. We are currently depositing the most significant geochemical signature in Earth's recent history, the Anthropocene layer. Elevated carbon dioxide, microplastics in marine sediment, isotopic signatures from nuclear testing, mass extinction markers in the fossil record. This layer will likely remain detectable for millions of years in some form. Geologists in the distant future, if they exist, will probably find it. But they will find chemistry, not cities. They will find ratios and anomalies, not skylines or satellites. The thing itself will be gone. Only the shadow will remain. A faint chemical whisper in old stone, testifying that something once happened here, without being able to say what. This is the architecture of planetary amnesia. Not a violent destruction, not a catastrophic erasure, but a slow, systematic, impersonal dissolution of everything that was ever made or built or known. Earth runs this process on everything without exception, applying the same geological indifference to a trilobite shell as to a skyscraper, to a mountain range as to a civilization's entire material legacy. The timescales vary, the outcome does not. We are living in the brief window between construction and erasure, a window that feels permanent because human lifetimes are too short to perceive the movement. But from the planet's perspective, from the perspective of 4.5 billion years of continuous geological operation, we are already in the process of being dissolved, already being processed, already on the way to becoming the thin, strange layer of rock that something else might stand on someday, if anything is left to stand. Everything we built is already in transit. Given enough time, nothing we built survives. In 2018, a paper appeared in the International Journal of Astrobiology that most people never read. It was written by two scientists, Adam Frank, an astrophysicist at the University of Rochester, and Gavin Schmidt, director of NASA's Goddard Institute for Space Studies. It was not a fringe publication. These were not fringe researchers. The journal was peer-reviewed. The authors were credentialed, careful, and precise. And the question they were formally asking, in the language of academic science with citations and methodology and structured argumentation, was this: if an industrial civilization had existed on Earth before us, would we be able to detect it? Their answer was, probably not. Read that again, slowly. Not, definitely not. Not, the question is absurd. Probably not. A formal scientific paper published in a legitimate peer-reviewed journal, authored by a NASA director and a professor of astrophysics, concluded that a prior industrial civilization on Earth would likely be undetectable with our current methods. They named their framework the Silurian hypothesis, a deliberate reference to a Doctor Who episode involving intelligent reptiles who inhabited Earth before humans. And they were careful to clarify that they were not claiming such a civilization existed. They were asking something more structurally important. Could we know either way? And the answer they arrived at, after systematic analysis, was deeply unsettling. We could not. This is where the argument changes register entirely. Because up to this point, the idea of prior civilization can be filed under speculation. Interesting, provocative, but ultimately unprovable. What the Silurian hypothesis does is something more precise and more disturbing. It doesn't argue that prior civilization existed. It argues that the absence of evidence for prior civilization cannot be interpreted as evidence of its absence because our detection methods are fundamentally insufficient for the timescales involved. It doesn't assert a hidden history. It exposes a blind spot. And that blind spot is structural. It's built into the geology of the planet and the limitations of the science we use to read it. That distinction matters enormously. One claim requires belief without evidence. The other requires only the honest acknowledgement that our tools have limits, and that those limits are severe enough to render certain questions unanswerable with current methodology. The Silurian hypothesis is the second kind of claim. It is epistemologically rigorous. It is, in fact, a more conservative and careful position than the confident assertion that we are definitely the first. Because that confident assertion assumes a completeness of the geological record that simply does not exist. So, what would the evidence actually look like if it existed at all? Frank and Schmidt worked through this systematically. They began with the question of what signature a civilization like ours leaves in the geological record. Not the buildings, not the infrastructure, but the chemical and isotopic traces that industrial activity produces at scale. The burning of fossil fuels, the mining and redistribution of metals, the introduction of synthetic compounds, the alteration of carbon and nitrogen cycles, the disruption of biodiversity sufficient to register as an extinction event in the fossil record. These are the kinds of signatures that leave geochemical marks, marks that, under the right conditions of preservation, could persist in rock layers for millions of years in detectable form. The problem is that those marks would be subtle, vanishingly subtle. A slight anomaly in carbon isotope ratios across a geological boundary. A marginal excess of certain trace metals in a narrow sediment band. An extinction signature without an obvious astronomical or volcanic cause. Nothing that would, on its own, compel interpretation as the product of intelligence. Everything that could be, and currently is, explained by natural processes. The ghost evidence of a prior industrial civilization would be indistinguishable in most respects from the noise of ordinary geological variation. Not because it isn't there, but because the signal and the noise occupy the same frequency. But that's not the real problem. The real problem is that we have already found anomalies that fit this profile. And we've explained them conventionally without ever seriously interrogating whether the conventional explanation is the only possible one. The Paleocene-Eocene thermal maximum is the most discussed example. Approximately 56 million years ago, global temperatures rose by 5 to 8 degrees Celsius over a period of roughly 20,000 years. Extraordinarily rapid by geological standards. The carbon isotope record for this event shows a dramatic negative excursion, a sudden massive injection of isotopically light carbon into the atmosphere and ocean system. Scientists attribute this to a combination of volcanic activity, methane hydrate destabilization, and orbital forcing. That explanation has substantial supporting evidence. It is probably correct. But the honest version of the scientific record also notes that the full mechanism is still debated. The carbon source is not entirely resolved, and the magnitude of the event exceeds what current models cleanly account for. Frank and Schmidt did not claim the PETM was caused by prior civilization. They used it to illustrate the methodological problem. If an industrial civilization had existed and collapsed in the run-up to such an event, contributing to the carbon anomaly, the additional signal would be buried within a natural event of similar character. The civilization's contribution would be, in practical terms, invisible. Not because it was small, but because it would be chemically coincident with a natural process that produces the same kind of signature. The signal would exist. We would be unable to extract it from the background. This is what detectability failure looks like at geological timescales, not a clean absence. A contaminated signal. Evidence folded inside evidence, the artificial indistinguishable from the natural, the record too compressed and too degraded to separate one from the other with any confidence. And there is another layer to this problem that rarely receives sufficient attention. Our geological record is not continuous. It is fragmentary. The rock layers that survive to be studied represent a fraction, in some periods a very small fraction, of what was originally deposited. Erosion removes layers. Subduction destroys them. Metamorphism alters them beyond chemical legibility. The periods of deep time that we understand best are the ones where preservation conditions happen to be favorable in the specific locations where geologists have happened to look. There are vast stretches of Earth's history where the record is thin, ambiguous, or simply absent. Civilization that existed during one of those poorly preserved intervals would have even less chance of leaving detectable traces than one that existed during a period of better geological record-keeping. It gets worse. Consider the specific problem of synthetic materials. One of the most distinctive signatures of our current civilization is the production of compounds that do not occur naturally. Certain plastics, industrial chemicals, artificial isotopes from nuclear activity. These compounds are, in principle, highly anomalous. If future geologists found them in rock layers, they would immediately recognize them as indicators of intelligent industrial activity. But the question is whether such compounds survive millions of years of geological processing in recognizable form. Most organic polymers, plastics, do not. They break down under heat, pressure, and chemical interaction into their constituent elements, which are then indistinguishable from naturally occurring carbon, hydrogen, and oxygen in the surrounding rock matrix. The smoking gun dissolves. What remains is carbon. Just carbon, slightly misplaced. The materials most likely to persist over geological timescales are certain ceramics and some metal alloys, but only if they are buried in geochemically stable environments, away from hydrothermal activity, away from subduction zones, in conditions of low oxygen and moderate temperature. Those conditions exist in limited areas of the continental crust. They require a geological coincidence of preservation that we cannot count on, and that, over tens of millions of years, is statistically improbable for any specific deposit. We can calculate the probability that any given artifact from our civilization survives recognizably for 50 million years. The number is not encouraging. It approaches zero for most material categories. What this means is that the question, did prior civilization exist on Earth, is not primarily a question about history. It is a question about the limits of knowledge itself, about what it means to know something happened when the evidence-generating mechanisms of that event have been systematically erased by the same physical processes that keep the planet functioning. It is a question about whether absence of detection and absence of occurrence can ever be cleanly separated in deep geological time. And the answer, the honest, scientific, methodologically careful answer, is that for certain timescales and certain types of evidence they cannot. That is what makes the Silurian hypothesis significant. Not as a claim, as a framework. It formalizes something that geology has always implied but rarely stated directly, that there is a detection horizon in Earth's past beyond which the absence of evidence for something cannot be taken as confirmation it didn't exist. That horizon sits somewhere in the range of a few million years, depending on the type of evidence and the preservation conditions. Beyond it, the rock record cannot reliably distinguish between a planet that never hosted advanced life and a planet that hosted it multiple times and processed those civilizations completely. We live on a planet that is 4.5 billion years old. The detection horizon is a few million years back. Everything beyond that horizon is, in a meaningful epistemological sense, dark. Not dark meaning certainly empty. Dark meaning inaccessible. Dark meaning that the methodology we use to know things has reached its operational limit, and what lies beyond it is genuine uncertainty, not confirmed absence. Science arrived at this conclusion honestly, through peer review, through careful analysis, through the work of researchers who had no stake in the answer being yes or no, only in the answer being accurate. And the accurate answer is that we do not know, and that not knowing is the scientifically correct position, not a failure of inquiry. A civilization can exist, it can build, it can alter a planet, it can collapse, and it can leave almost nothing 5 times. At minimum 5 times in the history of complex life on Earth, something has intervened with enough force to collapse the majority of living species on this planet. Not a percentage. Not a significant minority. The majority. In some cases, more than 90% of all species alive on Earth were eliminated within a geological instant. A window of time so brief measured against the planet's history that it registers as barely a boundary line in the rock. A thin, dark layer. An abrupt chemical shift. A before and an after separated by events so catastrophic that the planet that existed on the other side of them was, in many meaningful biological and geological senses, a different world. We call these the mass extinctions. We teach them as episodes of natural history. We discuss them with the clinical detachment that comes from knowing they happen to other things, in another time, to creatures that had no cities, no tools, no warning systems, no understanding of what was coming. And that framing, that comfortable distancing framing, has allowed us to engage with the concept intellectually while never fully absorbing what it actually means. What it means is this: the planet has been wiped clean before, multiple times, with a thoroughness that makes the word destruction feel inadequate. And if anything of complexity and intelligence had existed before each of those events, it would have been erased as completely as everything else. Not selectively, not partially. Erased. The most famous reset is the one that ended the Cretaceous period approximately 66 million years ago. The object that caused it, a rock roughly 10 to 15 kilometers in diameter, struck what is now the Yucatan Peninsula of Mexico at a velocity of approximately 20 kilometers per second. The energy released in that impact exceeded the combined yield of every nuclear weapon ever built by a factor so large that the comparison becomes meaningless. The immediate effects were local and total. Vaporization of the impactor, and significant volumes of surrounding rock, a fireball of superheated gas expanding outward at supersonic speed, a seismic event registering somewhere around magnitude 11, and a tsunami hundreds of meters tall radiating outward across the surrounding ocean. All of this in the first minutes. The global effects took longer. Ejecta, pulverized rock and sulfur compounds thrown into the upper atmosphere, dispersed around the planet and reduced incoming sunlight so dramatically that photosynthesis largely ceased. Global temperatures dropped. Plant life died. The food chains built on plant life collapsed from the bottom up. Herbivores starved. Carnivores followed. Within months to a few years, the estimates vary, and somewhere between 75 and 80% of all species on Earth were extinct. The non-avian dinosaurs, which had dominated the planet's terrestrial ecosystems for over 150 million years, were gone. Entirely and permanently gone. In geological terms, overnight. 66 million years. That is how far back the most recent of Earth's great resets occurred. In the context of complex life's 600 million year history on this planet, that event is relatively recent. The earlier resets were older and, in some cases, more severe. The Permian-Triassic extinction event, approximately 252 million years ago, is the most destructive biological catastrophe in Earth's documented history. It eliminated an estimated 90 to 96% of all marine species and approximately 70% of terrestrial vertebrate species. The ocean for a period was nearly biologically dead. The trigger was not an asteroid, it was the Earth itself. Specifically, a volcanic event of almost incomprehensible scale in what is now Siberia, where flood basalts poured out across an area larger than modern Europe over a period of roughly 1 million years. The volcanic activity released enormous quantities of carbon dioxide and sulfur dioxide, triggering runaway greenhouse warming, ocean acidification, and widespread anoxia, the depletion of oxygen in marine environment sufficient to kill marine life en masse. The planet essentially poisoned itself. Life recovered eventually, but the recovery took approximately 10 million years to restore anything resembling prior biodiversity. 10 million years of ecological reconstruction from near-total collapse. Before that, the late Devonian extinction events, there appear to have been multiple pulses, eliminated more than 70% of species approximately 375 million years ago. Before that, the Ordovician-Silurian extinction, approximately 445 million years ago, killed somewhere between 60 and 85% of marine species. Triggered, current evidence suggests, by a brief but intense ice age that locked vast quantities of water in glaciers, dropped sea levels dramatically, and destroyed the shallow marine environments where most complex life existed at the time. 5 major extinctions, dozens of lesser ones. A planet that has been returned to near baseline biological condition multiple times by forces ranging from extraterrestrial impact to internal volcanism, to orbital variation to atmospheric chemistry collapse. A planet that does not treat the products of evolution, however complex, however successful, however dominant, as permanent. But that's not the real problem. The real problem is what these events mean for the possibility of prior civilization, and specifically for the question of why we don't find evidence of it. Because if advanced life did arise before one of these resets, if something with intelligence and technology existed before the Permian-Triassic boundary, or before the end Cretaceous event, or during one of the many smaller catastrophes distributed across the last 500 million years, that life would not merely have been killed. It would have been subjected to the same geological processing that followed each event: sedimentation, compression, chemical alteration, tectonic recycling. Its physical record would have been ground into the same thin, anomalous layer as everything else that died. And we would be trying to detect it from the other side of a catastrophe that reset the planet's surface conditions so thoroughly that even the dominant biological forms of the previous era left only fragmentary traces. The dinosaurs ruled this planet for over 150 million years. They were extraordinarily diverse, ecologically dominant, and biologically successful by any measure. And the totality of their physical legacy after 66 million years of geological processing is fragments, scattered bones in specific preservation conditions, footprints in hardened rock in specific locations, fragments of eggshell, trace fossils, and genetic material still being teased out of ancient specimens. 150 million years of planetary dominance, and we have fragments, not archives, not comprehensive records. Fragments from lucky preservation sites scattered across a geological record that represents, in total, a fraction of what was originally deposited. If something more fragile than bone, something like metal, like glass, like polymer, like processed stone, existed before the Permian-Triassic boundary and was subjected to 250 million years of subsequent geological activity, including the catastrophic conditions of the extinction event itself, nothing would remain. Mathematically, structurally, chemically, nothing. It gets worse. The time intervals between these resets are not empty. They are long periods of biological and geological activity, during which the accumulated physical record of the previous era was being continuously processed and degraded. The 100 million years between the Ordovician extinction and the Devonian extinction were not a period of planetary stillness. They were a period of active tectonics, active erosion, active volcanism, active ocean chemistry fluctuation. Every year of those 100 million was another year of geological digestion, applied to whatever the Ordovician world had left behind. By the time the Devonian event occurred, whatever physical record the Ordovician world might have contained had already been subjected to 100 million years of degradation, before the next catastrophe added its own layer of destruction on top. Stacking extinctions on top of geological processing, on top of tectonic recycling, on top of erosion, on top of chemical alteration produces a compounding erasure that operates not just on artifacts but on entire categories of evidence. We are not talking about records becoming harder to read. We are talking about records ceasing to exist in any form that could be called a record at all. And yet the extinctions keep coming. They are not historical anomalies. They are features of the planet's operating behavior. They occur on irregular but recurring timescales, driven by forces entirely indifferent to what was living through them. The asteroid that ended the Cretaceous did not target the dominant species. It struck a random point on the planet's surface and let physics do the rest. The Siberian volcanic event that ended the Permian was not triggered by what was living above it. It was driven by mantle convection dynamics that had been building for millions of years before any of the species it killed even existed. These forces do not respond to complexity. They do not spare intelligence. They do not recognize the difference between a bacterium and a civilization. The next reset is not a hypothetical, It is a certainty. The geological record makes this clear. Not in any specific time frame that should produce immediate alarm, but on the scale of planetary history, another event of mass extinction magnitude is not a possibility, Nynand. It is a scheduled feature of the planet's long-term behavior. Impact events continue to occur. The solar system is not empty. Supervolcanic systems, Yellowstone, the Campi Flegrei in Italy, the Taupo volcanic zone in New Zealand, remain active and periodically restless. Long-term orbital mechanics continue to produce climate cycles. The same menu of catastrophic mechanisms that cleared the biological slate multiple times in the past remains in operation. The interval between events varies. The events themselves do not stop. What this means for the question at the center of this inquiry is stark. If you are asking whether prior advanced civilization could have existed and been erased, you are not constructing a hypothetical. You are asking whether the mechanisms capable of performing that erasure are real and historically active. They are. The planet's own record proves it. The extinctions happened. The erasures happened. The resets happened. 5 of them major, dozens minor. A planet that has cleared its own biological slate repeatedly, with no preference for complexity, no exception for intelligence, no preservation of achievement. The forces that could have ended a prior civilization are not theoretical. They are geological fact, documented in rock layers across every continent on Earth, confirmed by chemistry, confirmed by biology, confirmed by physics. They happened. They will happen again. And anything that existed before them, however advanced, however permanent it believed itself to be, encountered the same endpoint as everything else. Life doesn't end slowly. It ends instantly. The question sounds simple. If a civilization existed before us, where is it? Where are the ruins? Where are the artifacts? Where is anything, any object, any structure, any manufactured thing that would confirm the existence of intelligence before our own? The question sounds simple because we are unconsciously applying the logic of human-scale archaeology to a problem that operates on geological timescales, and that category error is doing enormous damage to our ability to reason clearly about this. When we excavate ancient Rome, we find things: walls, roads, coins, pottery, pipes, the physical residue of complex civilization. When we excavate Egypt, we find things. When we excavate Mesopotamia, we find things. And our intuition, built from this experience, tells us that civilizations leave material behind, that the signature of intelligence is physical, durable, and recoverable. That intuition is correct, but only within a specific and very narrow time frame. The time frame of human archaeology spans, at most, a few tens of thousands of years. Within that window, under reasonably favorable conditions, stone and ceramic and metal can survive. The intuition works. Extend the window to 1 million years and the intuition begins to fail. Extend it to 10 million and it fails completely. Extend it to 100 million and the entire conceptual framework of ruins and artifacts and physical evidence of civilization stops being applicable. At those timescales, the question is not where the ruins are. The question is whether the concept of a ruin is physically meaningful at all. Let us be precise about what happens to the materials civilizations use. Steel, the structural backbone of modern industrial civilization, oxidizes. In buried, oxygen-exposed environments, Iron alloys have a functional persistence of thousands to tens of thousands of years before corrosion renders them unrecognizable as manufactured objects. Even in highly favorable low-oxygen burial conditions, the time frame extends perhaps to hundreds of thousands of years before the metal chemistry becomes indistinguishable from naturally occurring iron mineral deposits. In geological time, millions of years, steel does not survive. It becomes rust, then iron oxide, then, after sufficient metamorphism, simply a marginal enrichment in the iron content of surrounding rock. Not a beam, not a bolt. A faint statistical irregularity in a geochemical sample. Concrete, modern Portland cement concrete, fares somewhat better in certain conditions. It can survive in stable burial environments for millions of years in a form that retains some structural coherence. But even concrete, given sufficient time, pressure, and chemical interaction with groundwater, disaggregates. Its mineral components re-equilibrate with the surrounding geology. The structured thing becomes unstructured material. The artificial becomes indistinguishable from the natural, and that is the core problem. Our civilization produces compounds and structures that are artificially arranged versions of materials that occur naturally in the Earth's crust. When the artificial arrangement breaks down, and given sufficient time, it always does, the materials return to their natural distribution. The manufacturing signature disappears. What remains is chemistry, not form. Glass, the major material of modern civilization, has a long-term persistence that depends heavily on environment. In stable, dry, cool burial conditions, glass can survive for millions of years. In hydrothermal environments, in acidic groundwater conditions, in high-temperature scenarios associated with burial and compression, glass dissolves and its chemical components are absorbed into the surrounding sediment. Silica, the primary component of most glass, is extremely common in the Earth's crust. A dissolved glass object becomes indistinguishable from the surrounding geology in its elemental composition. Again, the signature disappears. But that's not the real problem. The real problem is that even in the best-case scenario, where manufactured materials survive in chemically recognizable form for millions of years, we would need to find them. And finding them requires looking in the right place, in the right rock layer, with the right analytical method, motivated by the suspicion that something is there. Our current geological survey of the planet is comprehensive in some regions and nearly absent in others. The deep ocean floor, which covers the majority of the planet's surface, has been mapped with high resolution in only a fraction of its extent. The subsurface geology of large portions of the continental crust remains poorly characterized. We are working from a sample, and that sample is biased toward accessible locations, toward economically interesting formations, toward the geological intervals most relevant to questions humans have historically cared about. Fossil fuels, mineral resources, recent climate history. We have not been systematically searching for anomalies consistent with prior industrial activity, because until very recently, that question was not considered scientifically legitimate enough to warrant a survey design. It gets worse. Consider the orbital environment. Our current civilization has placed thousands of artificial objects in Earth orbit, satellites, space stations, debris fields. These objects, in many cases, are in relatively stable orbits that could, in principle, persist for millions of years before atmospheric drag or gravitational perturbation brings them down. A researcher examining Earth from space in 10 million years might, theoretically, detect anomalous metallic objects in stable orbit as evidence of prior technological civilization, evidence more durable in some respects than anything on the planet's surface. But here's the limiting factor. Orbital decay timescales vary enormously depending on orbital altitude. Low Earth orbit objects typically deorbit within decades to centuries due to atmospheric drag. Only objects in very high orbit, geostationary and above, have persistence timescales extending to millions of years, and even those are subject to gravitational perturbation, solar radiation pressure, and the eventual expansion of the upper atmosphere during periods of elevated solar activity. The orbital record of our civilization, the evidence written in space rather than rock, would also degrade and largely disappear over geological time. The escape routes from planetary erasure have their own erasure mechanisms. What would survive? The most durable physical evidence of our civilization on geological timescales is likely not our structures or our machines. It is our chemistry. Specifically, the global geochemical signature of industrial activity embedded in sedimentary rock currently forming at the bottom of lakes, oceans, and peat bogs around the world. This is the Anthropocene layer. Elevated concentrations of certain carbon isotopes, atmospheric chemistry changes recorded in polar ice, which would eventually compress into metamorphic rock, microplastic distribution in marine sediment, heavy metal anomalies in lake bed cores, a biodiversity collapse visible in the fossil record as an abrupt extinction horizon. This chemical signature, preserved in the right lithological context, could remain detectable for tens of millions of years. But it would not look like civilization. It would look like a geochemical anomaly, an unusual carbon excursion, an inexplicable spike in certain metal concentrations, a puzzling extinction event without an obvious physical cause. No impact crater, no volcanic province, just a thin layer of chemically strange rock separating a before and after in the biological record. A future geologist studying that layer, without prior knowledge of our civilization's existence, would likely conclude that an unusual natural event occurred. A burst of volcanism, perhaps, or a rapid methane release. They might consider alternative explanations. But the default interpretation, in the absence of culturally transmitted knowledge about the Anthropocene, would be natural. And that is precisely the point. Our own civilization's most durable geological legacy, the evidence most likely to survive tens of millions of years, would be routinely misinterpreted by a scientifically sophisticated future observer who lacked the cultural context to ask the right question. Our chemistry would be there. Our meaning would be gone. The signal exists. The interpretation requires a framework that only exists if you already know what to look for. Now apply that insight backwards. If a prior industrial civilization existed and left a similar chemical signature in the rock record, and if we have not been looking for it with a framework that asks the right questions, we might have already found it and explained it as something else. The Paleocene-Eocene thermal maximum's anomalous carbon signature. Certain unusual metal enrichments in Precambrian banded iron formations. Unexplained extinction pulses in the deep Cambrian record. None of these are evidence of prior civilization, but they are examples of the kind of signal that prior civilization might leave. And the point is that we process them through frameworks that don't include that possibility. Not because the possibility has been evaluated and rejected, but because it has mostly not been part of the interpretive toolkit. The absence of a dedicated search is not the same as a dedicated search returning negative results. We have never searched. We have noticed things and explained them with the best available natural mechanisms. That is good science, working within its established paradigm. But it means that the absence of detected prior civilization in the geological record cannot be taken as confident evidence that no prior civilization existed. It can only be taken as evidence that the standard geological interpretation process, operating without that question in view, has not flagged an anomaly compelling enough to demand that question be asked. The ruins are not sitting somewhere waiting to be found. The ruins are already gone. What remains, if anything remains, is a faint chemical whisper in old rock. Already found, already explained, already filed under natural causes, already moved past. Absence doesn't mean it never happened. Hold one image in your mind. A single line, stretched horizontally across your field of vision. The line represents the entire age of the universe, 13.8 billion years. Every event, every galaxy formation, every stellar generation, every planetary system, every moment of biological and chemical complexity that has ever occurred anywhere in the observable cosmos. All of it compressed into this one line. Now locate Earth's formation on that line. It appears at roughly the 2/3 mark, about 4.5 billion years from the right end. Now locate the emergence of complex multicellular life on Earth. That appears much closer to the right, about 600 million years from the end. Now locate the entire span of human civilization. Every empire, every language, every technology, every war, every monument, every idea. From the first agricultural settlements to this moment. You cannot see it. At this scale, the entire recorded human story is a mark too small to render with any instrument we currently possess. Not a thin line, not a pixel. A quantity so small relative to the scale of the line that it rounds to zero. This is not a rhetorical device, it is a mathematical reality. And sitting with it, actually sitting with it, rather than nodding and moving on, changes something fundamental about how the question of prior civilization looks. Because the question is not really, did something exist before us? The question is, given these timescales, how many times could something have existed and ended without leaving any trace we can access? And the answer to that question, when you do the arithmetic honestly, is not a small number. Complex life has existed on Earth for approximately 600 million years. Our civilization has existed in recognizable form for about 6,000 years. That ratio, 6,000 to 600 million, means that modern human civilization represents 1 part in 100,000 of the available time frame for complex life on this planet. If you assumed conservatively that a technological civilization requires at least a few million years of biological prerequisite complexity to develop, which is a reasonable minimum, then the 600 million year window of complex life on Earth could theoretically accommodate dozens to hundreds of independent technological civilizations, each arising and collapsing within its span. Not simultaneously, sequentially. Each separated from the next by millions of years of recovery and re-evolution. Each leaving the kind of geological signature that would be processed and made invisible by the time the next one arrived. The mathematics do not require that this happened. They only require that it was possible repeatedly within the time frame available, and that the erasure mechanisms we have already established are efficient enough to prevent detection of each event by its successors. But that's not the real problem. The real problem is that we instinctively measure time in human increments. A century feels long, a millennium feels ancient, 10,000 years feels like an incomprehensible depth of history. And this scaling intuition, which works reasonably well for navigating human affairs, catastrophically fails when applied to geological and cosmological time. It causes us to vastly underestimate the quantity of time available for things to happen, and vastly overestimate the significance of the interval during which we have been observing. Consider a specific comparison. The non-avian dinosaurs existed as a group for approximately 165 million years. During that span, they diversified into hundreds of ecological niches, achieved body masses ranging from the size of a sparrow to the size of a building, demonstrated behaviors that in some lineages included complex social structure, long-distance migration, and extended parental care, all markers that, in other contexts, we associate with the precursors of intelligence. Modern humans have existed for 300,000 years. The dinosaurs had 550 times more time on this planet than we have had. They were, by every available metric, extraordinarily successful. And they are gone. And their physical legacy, after 66 million years, is fragments. We tend to imagine ourselves as the culmination of something, as the endpoint toward which planetary history was tending. That narrative is psychologically powerful and epistemologically empty. Earth's history is not a progression toward humanity. It is a series of biological experiments conducted by evolutionary pressure within changing environmental conditions, producing whatever complexities happen to emerge from the available chemistry and the available time, and then periodically resetting those experiments with catastrophic events. We are the current iteration of that process. We are not its conclusion. It gets worse. The cosmic timescale problem extends beyond Earth. The universe is old enough and galaxy formation has been occurring for long enough that, if the development of technological civilization is possible at all, which our own existence confirms, it has had time to occur many times over in many locations. The Milky Way alone contains several 100 billion stars, the majority of which are older than our Sun. Many of those stars host planets. Many of those planets orbit within habitable zones. If even a small fraction of them hosted technological civilizations at any point in the galaxy's history, the number of such civilizations is not small. But here we are, apparently alone, or at least receiving no confirmed signal from anyone else. Fermi's paradox, the great silence. One of the most serious proposed resolutions to that paradox is the possibility that technological civilizations are inherently unstable, that they arise, develop, and collapse within windows of time too brief to make contact, let alone leave lasting marks on the universe. The same forces that threaten to erase prior civilizations on Earth, catastrophic impacts, volcanic events, climate collapse, and perhaps the civilization's own technological consequences, might operate universally, making advanced intelligence not a stable feature of the cosmos, but a brief recurring flicker. Something that happens, burns for a moment of geological time, and is extinguished before it can become permanent. Under that model, civilizations are not rare events separated by vast cosmic distances. They are common events separated by vast cosmic timescales, arising and collapsing in staggered sequence across the galaxy's history, each one invisible to its predecessors and successors because the time gaps between them are measured in millions of years, and the evidence of each one is erased by the planet's geological recycling, before the next one develops the capacity to search. We exist in one such window. We have no reason to believe our window is different from the others, more durable, more significant, more likely to persist. Our technology is advancing rapidly, which can be read as a sign of either extraordinary resilience or extraordinary fragility, depending on which part of our trajectory you examine most carefully. Our capacity to alter the planet's chemistry, its climate, its biological diversity, and potentially its physical stability has increased faster than our demonstrated capacity to govern those alterations wisely. That observation does not lead anywhere comfortable when held against the background of a universe where civilizational windows appear to be brief. The cosmic scale problem is ultimately a problem of perspective. From inside a civilization, from within the 6,000-year window of recorded human history, with its accumulated culture and knowledge and narrative of progress, it is nearly impossible to see ourselves as temporary. The continuity of memory, the inheritance of prior generations' achievements, the sense of a shared project extending forward and backward through time, all of these create the illusion of permanence. We feel like something that will persist, like something that matters cosmologically, that has earned a durability proportional to its complexity. That feeling has no supporting evidence at planetary or cosmic scales. Civilizations do not earn permanence. They either achieve it, and there is, so far, no confirmed example of any civilization achieving it at geological timescales, or they don't. The line is long. The human mark on it is undetectable at full scale. Whatever came before us occupied other positions on that line. Positions that, from our location, are invisible not because they were empty, but because the distance in time is so enormous that everything that happened there has been processed into silence. And from some future position on that same line, a position that may or may not be occupied by anything that remembers us, our own position will look the same. A thin chemical layer, an anomalous isotope ratio, a brief, strange, energetic interval that ended as all such intervals end, and was absorbed into the planet's ongoing geological operation without comment. We are not permanent, we are temporary. There is a specific kind of vertigo that comes from recognizing a pattern you cannot unsee. It is different from ordinary fear, different from ordinary uncertainty. It is the sensation of a frame expanding, the borders of a picture pulling back to reveal a context so much larger than the image you were examining that the image itself becomes something different. What looked like an isolated event becomes one instance of a recurring process. What looked like history becomes cycle. We are in that moment now. If everything this inquiry has established holds, if the geological erasure mechanisms are as efficient as the evidence indicates, if the extinction events are as thorough as the rock record confirms, if the detection horizon is as impenetrable as the Silurian hypothesis concludes, then we are not looking at the story of a unique civilization arising from a blank slate. We are looking at one iteration of a process that the planet may have run before, possibly multiple times, with consistent structural features. Complexity arises, intelligence emerges, civilization develops, and the geological cosmological apparatus that has never favored permanence eventually absorbs the whole project and continues without it. This is the cycle hypothesis, not as mysticism, not as pseudoscience, but as the logical extension of everything we know about how Earth operates, how life evolves, how catastrophes reset biological baselines, and how little time we have actually been here relative to the time available for this sequence to repeat. The cycle doesn't require that every iteration was human. It doesn't require that prior civilizations were technologically similar to ours, or biologically similar, or that they followed the same developmental path. Life has had 600 million years of complex biological experimentation to work with. The specific pathway that led to Homo sapiens, the primate lineage, the bipedalism, the particular brain architecture, and is one pathway among the millions that evolution has explored. An intelligence that arose in the Carboniferous period, or the Triassic, or the Eocene, might have been built on entirely different biology, used entirely different chemistry, built entirely different structures. We would not recognize its artifacts even if the geological conditions had preserved them, which, as established, they almost certainly have not. But that's not the real problem. The real problem is what the cycle, if it is real, implies about our own position within it. Because if civilizations arise and collapse in repeating sequence on this planet, driven by a combination of internal instability and external catastrophic forces, then we are not exempt from the cycle, we are inside it. And the question of whether we are the first civilization is philosophically interesting, but ultimately secondary to a more urgent question. Are we capable of becoming the last? Not last in the sense of final destruction, but last in the sense of the first to break the cycle? The first to achieve the kind of stability and resilience that transforms a temporary flicker into something that persists at geological timescales? The honest answer is that we don't know. We are in the very early stages, 6,000 years into a process that, by comparison to the cycles it may be repeating, has barely begun. Our technology is powerful enough to alter the planet's chemistry, but not yet powerful enough to reliably deflect the cosmic threats that have previously ended dominant life forms. Our social and political structures are sophisticated enough to coordinate large-scale activity, but not yet stable enough to guarantee long-term coherence against either internal fragmentation or external shock. We are, in geological terms, a young civilization. Young civilizations have not previously demonstrated the capacity for indefinite persistence. We have no model for what that looks like, because no prior example, on Earth or so far as we can detect, anywhere in the observable universe, has left one. It gets worse. There is a particular cruelty embedded in the cycle hypothesis that becomes visible only when you examine it at full resolution. Each iteration of the cycle, each civilization that arose and developed and ended, presumably reached a point where its members were capable of asking the same questions we are asking now. Capable of looking at the geological record, capable of understanding time, capable of recognizing their own fragility within it. And each iteration presumably found the same answers we are finding. That the planet is not a safe harbor, that the geological and cosmic forces operating around it are indifferent to complexity, that the window is brief and the mechanisms of erasure are efficient, and each iteration, if the cycle is real, reached some terminal point regardless of its awareness. Knowledge of the danger did not in itself produce survival. Awareness is not protection. Understanding is not immunity. The capacity to recognize a pattern is not the same as the capacity to break it. These are uncomfortable propositions because they suggest that the very qualities we rely on, intelligence, knowledge, scientific understanding, may be insufficient by themselves to alter the fundamental condition of civilizational impermanence. That the problem might not be ignorance but something more structural. something embedded in the relationship between complex, energy-intensive civilization and the planetary and cosmic environment in which all such civilizations must operate. We do not know if that is true, but we know that it is a question worth taking seriously, precisely because it is the question that every prior civilization, if prior civilizations existed, presumably failed to answer with sufficient practical effectiveness to alter its outcome. The archaeological silence around us might not be evidence of empty time. It might be evidence of repeated attempts, repeated collapses, and a geological record that treated each attempt with the same patient indifference it applies to everything else. What we choose to do with that possibility is, in the most literal sense, the most important question our civilization has ever faced. Not because it determines whether we were first, but the question is interesting, but ultimately academic. But because it determines whether we are last. Whether this iteration, armed with more knowledge of the planet's history and more understanding of the forces arrayed against persistence than any prior iteration could possibly have had, finally breaks the pattern. Finally becomes the civilization that the geological record, 50 million years from now, registers not as a thin chemical layer between two silences, but as something that continued, adapted, and refused to be erased. That outcome is not guaranteed. It may not even be probable, but it is the only direction in which any of this inquiry points that has practical consequence. This may not be the first time we've been here. Stand somewhere quiet, not quiet in the human sense. Not a room with the television off, not a park without traffic noise. Quiet in the planetary sense. A place where the sounds are geological, wind moving over stone, water finding its level, the deep structural silence of rock that has been sitting in the same formation for 50 million years. A desert cliff face. A high mountain plateau. An exposed coastal headland where erosion has cut through layered sedimentary rock and left the cross-section visible like the pages of a book that has been pressed too hard and too long to still be readable. In that silence, understand what the silence actually is. It is not emptiness. It is the sound of erasure, continuous and impersonal, operating at a frequency below human hearing, but above any threshold of consequence. The wind is not simply moving air. It is removing material, grain by grain, molecule by molecule, from the face of the rock, redistributing the substance of the planet's history into the atmosphere, and the ocean and the sediment layers currently forming at the bottom of every body of water on Earth. Every moment that passes is a moment of planetary editing. Every weathered surface is a page being removed from the record. Every river delta is an archive, but an archive being written over continuously. The old text dissolved into the substrate before it can be read. This is the silence of Earth. Not the silence of nothing having happened, but the silence of everything that happened being processed, digested, and incorporated into the next version of the planet, without commentary and without preservation. We have been asking, through everything this inquiry has covered, whether something existed before us, whether the 600 million year history of complex life on this planet, with its repeated extinctions and resets and geological recyclings, could accommodate prior civilization, prior intelligence, prior technology, prior achievement that the planet subsequently erased. The honest answer we have arrived at is, yes, it is plausible. Scientifically, the question is open. The detection horizon is real. The erasure mechanisms are confirmed. The geological record is fragmentary. The absence of evidence is not evidence of absence when the evidence generation and evidence preservation conditions are as limited as they are. But there is a second question, quieter and closer to home, that has been running beneath this entire inquiry from the beginning. What will the silence sound like after us? We are currently the loudest thing this planet has produced. We have altered its atmosphere, its chemistry, its biology, its temperature profile, its ocean pH, its magnetic environment, its orbital debris field. We have inserted our signature into the geological record in more ways than any prior event in the last 66 million years. The Anthropocene layer will likely be detectable for tens of millions of years in one form or another. A thin, strange, chemically anomalous band of rock that future geology, if future geology exists to study it, will have to account for. But the layer will not contain us. It will not contain our cities, our language, our knowledge, our loss. It will contain chemistry. It will contain extinction markers. It will contain isotope ratios and metal concentrations, and perhaps a faint scattering of artificially synthesized molecules in the most favorably preserved deposits. It will be evidence that something happened without being able to say what. And it will be silent. In the same way that every other anomalous layer in the geological record is silent, present but unnarrated, legible only as data, stripped of meaning by the very processes of preservation that allowed it to survive at all. There is no way around this. It is not a problem to be solved by building better structures, or choosing more durable materials, or engineering longer-lasting archives. It is a feature of the relationship between the timescales of planetary geology and the timescales of civilization. Everything we are and everything we know operates within a window. The window will close. What persists after it closes will be a chemical shadow of a shadow. Evidence of our energy expenditure, not of our understanding. And if the silence that preceded us was not emptiness, if something else occupied a window before ours and left its own chemical shadow and layers of rock we have already found and explained away, then the silence after us will be the same kind of silence. Not nothing. Not proof of our non-existence. Just the next layer of an ongoing geological record that does not pause for significance, does not annotate its anomalies, does not preserve the stories of the things that burned through it. The question with which this inquiry began, how many civilizations destroyed Earth before us, may be permanently unanswerable. Not because the answer is no, not because the question is absurd, but because the planet we are asking does not keep records. It keeps rock. And rock, at geological timescales, tells chemistry, not history. We are here now. We are loud and complex and aware and asking questions that no geological process can answer. We look back at the silence and wonder what it contains. And eventually, not tomorrow, not in a century, maybe not for millions of years, but eventually, as certainly as the rock layers keep forming beneath us, we will become the silence. We will become the thing that something else, if anything else exists to wonder, looks back at and asks the same question about. We will be the mystery. One day, we will be the mystery.